Welcome back to my channel, students. Today we will learn about the uh, chapter number 6, Refraction of Light, for the 10th standard students. In this chapter we will study about the refraction of light, laws of refraction, refractive index, and dispersion of light. Okay, then uh, at first we recall some questions which we have already studied in the 8th standard. What is meant by reflection of light, and what are the laws of reflection? We have seen that generally light travels in a straight line. Because of this, if an opaque object lies in its path, a shadow of the object is formed. We have also seen in the previous classes how these shadows change due to the change in relative positions of the source of light and the object. But the light can bend under some special circumstances, as we will see below. But before that, some questions here given. That means two questions are given here. What is meant by the reflection of light? See the answer of that question. What is meant by reflection of light? When light is incident on the surface of an object, it is deflected in different directions. This process is called as reflection of light. Understood? Then question number 2 is asked in our textbook. That is, what are the laws of reflections? The first law of reflection is that the incident ray, the reflected ray, and the normal ray at the point of incidence lies in the same plane. And second law is that the angle of incidence is equal to the angle of reflection. Do you understand? These two laws and definition of the reflection of light we have already studied in the 8th standard class. But in this 10th standard we will learn about the refraction of light. Here I given here the diagram, that is a glass slab. When we enter the light to the glass slab, at that time, first of all the light is in air medium, then light enters to the glass medium, that is a denser medium, solid medium, and after that it goes to the air medium again. That means here 1, 2 and 3, there are three directions. Three directions means when the light enters through the glass, at that time the light is bent. See this in the figure. In the glass slab there is a bend of that direction of the light. We already we know the light always light travels in a straight line, but in this case, because of this change of medium, due to this change of medium, light first goes to the straight line, again then when it enters to the glass slab, at that time, see the diagram, there is a bend of the path. Then after that it also goes to the air medium, that means 3 mediums. See here, for that I will take some activity which is given in your book. That is, first activity is what? Take a transparent glass and fill it with the water. Here, see in the figure, I take a glass full of water and dip some portion of pencil vertically. I dip here the some portion of pencil dip into the water and observe the thickness of the portion of the pencil in water. If we students, if we observe the portion of the pencil, see here, portion of the pencil inside the water appears to be thicker than the portion above the water. That means if we insert the pencil in the glass of water of that glass, at that time the lower portion of the pencil, that means under the water portion of the pencil, is to be thicker than the portion of the water. Then take here another example. If the portion of the water, if the pencil is pressed in the insert in the glass is inclined, at that time the portion of the pencil appears to be broken near the surface of the water. See the diagram? In this diagram, I insert the portion of the we insert the pencil to the glass which is filled with water and observe to that pencil which is insert in the glass. See carefully the portion below the water, that means in the water, and the above surface of the image of the pencil above the pencil appears to be broken at the surface of the water. See here, this is the one activity. Then if we take the second activity, same case here also, keep a 5 rupees coin in a metallic vessel. If we take the metallic vessel, then keep the 5 rupee coin in a metal vessel and stop the slowly go away from that vessel. Stop at place when the coin disappears. Go slowly away from the vessel. At that time, you stop at a situation that the coin, when the coin disappears. Keep looking in the direction of the coin and ask your friend to go slowly. Ask the friend to slowly fill the water in the vessel. You will be able to see the coin once the level of the water reaches certain height. That means, see here in the diagram, if we observe, see here, blue colored is water, then real coin is in the downward at the base of the glass and appears to the eye the coin is, see here, coin appears here. That means if we observe to the coin at that time, this coin is seen at the upper side of the coin glass. That means coin appears here. See the diagram. here. Then in both the cases there is a change in direction of the light. That means from that two activity we can define refraction of light. That is, light changes its direction. Light changes its direction when going from one transparent medium to another transparent medium, and this is called as refraction of light. Okay, understood? See again, definition. Light changes its direction when going from one transparent medium to the another transparent medium. This is called as refraction of light. Okay, understood the definition of refraction of light? Then I will take here the third activity, which is given in the textbook. Which is this activity? If we take a glass slab on a blank paper and draw its outline and name that outline diagram, that is 4 points, that is PQRS. We take here rectangular glass slab. Draw an inclined straight line on the side PQ so that it intersects PQ at N. Press two pins vertically at 2 points A and B along the line. Then look at the pins A and B from the opposite side of the slab. Press the pins C and D vertically so that the image of the A and B are in the line with C and D. That means these 4 lines, if we observe at that time, pin A, B, C and D, these 4 pins, if we observe at that time, these 4 lines seen in a straight line direction. Okay, then now we can remove the chip glass slab, that is the pins, and draw a straight line going through the points C and D so that it intersects SR at point M. Join the points M and N. Observe the incident ray AN and emergent ray MD. See here again. The first refraction occurs when light rays AN in the glass slab light ray AN glass from air at point N on this side PQ. Then the refraction occurs when light enters air through the glass at point M. See here, point M on the side SR. For first refraction of angle, for the first refraction, the angle of incidence is I, while for the second it is I1. See in the figure, first refraction angle of incidence is I, near to the angle N, near to the point N, and another second angle of incidence is I1 at point M. The angle of refraction at N is R. See here in the figure. If we observe the figure, then I1 equal to R. I1 and R, these two angles are congruent, that is equal. In the second refraction, angle of refraction is I. See here, in the outer side of the slab, that is the angle of refraction is I, which is equal to I. Upper side of the glass slab, that is here seen, angle I. That means in the second refraction, the angle of refraction is E, which is equal to I on both parallel sides PQ and RS of the glass slab. That is upper side of the angle I and lower side of the angle E. These two angles are equal. Change in the direction of the light ray is equal but opposite in direction. See here again, the change in direction of the light ray is equal but opposite directions. Thus, the light may MD, see here this ray MD emerging from the glass slab. This light ray MD emerging from the glass slab is parallel to the incident ray AN. These here dotted blue dotted lines, these two rays are parallel to each other seen in the diagram. But the emergent ray is the somewhat displaced. See here, but the emergent ray is somewhat displaced with respect to the incident ray. That means emergent ray is displaced with respect to the incident ray. This is the diagram for the refraction of light passing through the glass slab. That we see in the diagram. See the diagram, students. First AN is the light ray which is in the air medium. Then when the light enters through the glass slab, at that time we get the ray MN. See here, MN. Then after that, when light pass from glass to air medium, that is ray MD. If we observe the diagram carefully, the direction of the light is a change in the glass slab. That means glass is medium and air medium. These two mediums are different mediums, and we know the definition of refraction of light. That is, light changes its direction when it passes through one transparent medium to another transparent medium. That means here air is also transparent medium, glass is also transparent medium. That means here we have two transparent mediums, that is air medium and that is air medium and glass medium. Okay, see again. Here we have to give one in the textbook two more questions. Will light travel through a glass slab with the same velocity as it travels in air? म्हणजे काय, लाईट व्हेलॉसिटी ग्लासमध्ये आणि बाहेर इतर मीडियममध्ये ग्लास स्लॅबमध्ये आणि ह्याच्यामध्ये सेम असेल का? व्हेलॉसिटी स्पीड जो आहे लाईटचा तो सेम असेल का? तर असणार नाही, हे लक्षात घ्या. Light will not travel through a glass slab with the same velocity as it travels in the air because glass slab blocks the path of light. Why? The glass slab blocks the path of light, so there is no same velocity as it travels in the glass and air medium. Understood? Then second question, will the velocity of light be same in all media? Velocity of light will be same in all media. No. Yes. Light is slowly down in transparent media such as air, water and glass slab. Do you understand this my video about the refraction of light? If you like this my video, then share with your friends and thumbs up and press the bell button. Thank you.